All right, everybody, welcome to this week's Office Hours, and another event-driven one, given all of the snow that's coming for the mountains, imminently starting to fall as I speak now, but really going to get going later tonight into tomorrow. So welcome, everyone. It's been a bit of a gap since the last one because the weather calmed down in California. In fact, it was quite dry and warm for a little while there, even some daily record highs in between everything else. So most of the state has gotten a chance to dry out. And much of the state, especially coastal, central, and southern California, did need that, given how much water has fallen recently and all the flood, but mainly mud and landslide type problems. There have been a couple of bigger landslides now in Ventura County, sort of as that soil column has become increasingly saturated. So even after the rains have ended, that soil column gets heavier because of all that accumulated water, and those slides can happen weeks and sometimes even months later. So the risk of mudslides now much lower, but landslides remains in Southern California after it has remained wet. Meanwhile, parts of Northern California, which haven't gotten as much rain so far this season, are in line to get quite a bit with this pattern, or in the case of anyone above about 3,000 or 4,000 feet, a whole lot of snow, which is probably even better news in a certain sense, because the one part of the state that hasn't been as wet as had hoped for this point in the season is the Sierra Nevada in particular. And although there has been recent improvement in the snowpack, in fact, I think I have the most recent numbers from this morning written down. Depending on where you are in the mountain chain, the current snowpack, snow water equivalent, ranges from about 76% of average in the southern Sierra to about 91% of average in the northern Sierra. So technically still below average everywhere, although not by a huge margin. The snow water equivalent is okay right now. It's reasonably high, although generally still below average, especially at lower elevations. And so this is one of those years where it feels worse if you're at 4,000 or 5,000 feet, because you've seen a lot of heavier snow events at very high elevations, but a lot of warmer events that didn't produce a lot of snow at 5, 6, 6,500 feet even. So a lot of that snowpack is at high elevations, not necessarily reflected as much in terms of what we're seeing where more people actually live up in the mountains. Of course, all of that is going to change dramatically over the next 48 hours when feet of snow just about everywhere. We will not be measuring in inches, but rather feet at almost all locations above 3,000 or 4,000 feet. So this will be an event that produces heavy to extremely heavy snowfall, even at elevations that have struggled so far this season to see meaningful accumulations. And this includes the Tahoe Basin all the way down and below lake level, where, again, 3 to 4 plus feet of snow will likely fall this weekend. And that's not on the mountain peaks. In the mountain peaks, it's going to be more like 5 to 10 feet. Not inches, but 5 to 10 feet of snow. So between 50 and 100 inches of snow this weekend in many places in the mountains. That is likely to set some top 5 daily or 2-day snow accumulations in some locations in the mountains. So this will be another snowstorm, probably for the record books in some places. And so when all is said and done, it's quite likely that Sierra snowpack will be significantly above average just about everywhere in as little as a week. So turnaround from snow drought and very little snow, conspicuously little snow at lower elevations all the way through part of February to a sudden increase in that snowpack even down to lower elevations. And speaking of lower elevations, the snow that we're going to see up in northwestern California, so in the hills and mountains above the north coast, as well as places like Shasta County, will be pretty low. This isn't going to be an extremely low snowfall event. So this isn't going to be like some of the storms we saw last year where we saw snow at low elevations we hadn't seen in years. This will not be like that event. Snow levels probably won't get much down below 1,500 feet, which is still pretty low given the significant accumulations that might occur at that level, but they're not going to get down to 500 feet or lower as they did last year. This is just not a cold enough air mass. It's cold, but not exceptionally cold. But it's It is where it is exceptionally cold is in the context of it being a very moist air mass. So we rarely get air masses this cold that are also this moist and associated with this much storm activity. So we definitely get colder air masses than this one in California, but they're usually much drier than this one. So of course they don't produce as much, if any, lower elevation snow. The lowest elevation snow events are usually those pretty moisture-starved air masses where you manage to get some scattered showers that dump snow at really low elevations. This is less likely to be like that, but it's an event that may produce very heavy snow accumulation up in northwestern California down to 1,500 or 2,000 feet. And of course, that's that elevation band that doesn't usually see more than a dusting of snowfall in many winters. And so to get a foot or so of snow at 1,500 or 2,000 feet, at 1,500 feet up in the northwestern part of California or in Shasta County or even down into Mendocino and Lake counties, that's going to affect some of the major highways like 101. It's going to affect a lot of the populated areas up in the hills and up near Clear Lake and elevations above that. So although they're not going to see the 5+ feet of snow that the Sierra Nevada will see up at 5,000 and 6,000 feet, even seeing 6 inches of accumulation in some of these places is going to cause problems because they're less accustomed to that kind of heavy wet snow accumulation, which causes big time problems on the roads. There aren't a lot of snow plows, and causes problems with the power infrastructure because, again, the power infrastructure is not necessarily set up to accommodate those heavy snow loads. So we're not going to see snow to super low levels, but at relatively low levels in those parts of the state, we're going to see a whole lot of heavy wet snow that's going to cause problems. Now, there will be a pretty sharp cutoff in the southern extent of that cold enough air. In fact, even in the San Francisco Bay Area, I don't think there's going to be much snow down below 2,500 feet, maybe 2,000 feet. So that keeps it pretty much above all but the highest peaks. This won't be one of those impressive low snow events in the Bay Area where you see tons of snow on all the hills. And certainly not in Southern California. A lot of the cold air isn't going to make it quite as far south in this case. Some snow up in the mountains, of course, but not down to super low elevations like we saw last year. So really with this event, the big story is going to be the Sierra Nevada and some of the other higher mountains in Northern California and in Central California, at least in the context of the Central and Southern Sierra as well, where there will be legitimate blizzard conditions developing later tonight into tomorrow. What this means is that this is probably not a weekend to go up to the mountains to ski for several reasons. One is that you just probably won't get there. In fact, I'm hearing reports that the Highway 80 is already shut down. It'll probably reopen briefly, but then close again, and possibly be closed for much of the weekend. Same with Highway 50, and of course any of the other routes up there. Don't even think about it in the winter anyway, during a big storm. So you probably won't be able to get there. If you do manage to get there, it will be a very dangerous drive. And once you get there, a lot of things are going to be closed, including probably the chairlifts at the ski resorts, because there's just going to be too much wind. Because this will be a legitimate blizzard. A lot of Sierra Nevada snowstorms, the wind and the snow are somewhat disconnected from each other. They don't occur at the same time. So the big wind events are often different than the big heavy snow accumulation events. But in this case, there's going to be extremely heavy snow and very strong winds at the same time. So winds gusting well above 50 to 60 miles an hour, even above 70 miles an hour on some of the peaks. And this will include not just the peaks for the stronger winds during the snow, but also the more populated areas. So South Lake Tahoe could see some power outage issues, the western slope as well, because there will be at those 850, 700 millibar winds, so they're above the surface, but of course the taller mountains intersect those pressure levels in the atmosphere. This will not be a super strong wind event at sea level, so this will not be like the early February event that caused all the wind damage in the Bay Area or along the north coast or the central coast. It'll be breezy to windy, but nothing exceptional. It'll probably be the third or fourth windiest storm this year in coastal areas, so probably not too big of a deal down at sea level in terms of wind, but up in the mountains this will be a very windy storm because the winds above the surface in this case are a whole lot stronger and will coincide with extremely heavy snowfall rates. What do I mean by extremely heavy? Well, 2-inch per hour snowfall rates will be widespread for long durations during this event, and could get as high as 5 inches per hour, so nearing half a foot of snow per hour sustained for multiple hours at times. There's no way that any road clearing crew can possibly clear that much snow that quickly, especially if you have 60-mile-an-hour winds and it's just blowing all around. So again, true blizzard conditions. What is a blizzard, by the way? It's not enough to have very heavy snowfall, and so the Weather Service will not issue a blizzard warning if it's just super heavy snow, as is more often the case in the mountains. Then they'll issue a more common winter storm warning. But in a true blizzard, you have sustained winds above a threshold for multiple consecutive hours, along with significant falling or blowing snow. And so when there's a blizzard warning for the entire Sierra Nevada, as there is right now for this event, that's a pretty strong signal that this is not an ordinary winter storm. And so, as I mentioned, I do think that it's plausible that some places will end up seeing a top 5 or top 10 all-time record 24-hour or 48-hour snow accumulation from this event, on the order of 3 to 5 feet at lower elevations and 5 to 8 plus feet, maybe even 10 plus feet in some of the peaks or the most orographically favored locations on the western Sierra Slope or along the crest. Again, this is over like a 48-hour period, so that's a lot of snow, and I know these are very snowy places, but even in that context, that's a whole lot of powder falling in a very short period of time. And again, remember that the chairlifts of the ski resorts can't operate if it's windy, and this will be a very windy storm, so it's quite likely that they just won't be running, even if you were able to get up there through the road closures and the treacherous travel conditions. So the official language is just don't try it. Pretty much, if you're not already there, don't try it until probably realistically Monday is when things might start to really calm down. And if you are up there, if you live up there, be prepared for a really big snowstorm. Really true blizzard conditions with multiple feet of snow and very strong winds, so potential for power outages, and the fact that roads probably aren't going to be cleared as quickly or as effectively as they normally would be, even during a significant winter storm, since this will be a big deal everywhere. And just because all the snowstorms have sort of fizzled out so far this year at lake level does not mean that this one will. In fact, this one just has a tremendous amount of cold air support. It's likely that snow levels will drop as precipitation intensifies during this event, which is the opposite of what has happened previously this winter during strong, warm atmospheric rivers. So even if it is starting out a little bit of rain right now in some places, that will quickly transition to snow and then eventually to fluffier, drier snow as that colder air mass occurs. There's just too much cold air and too much efficient precipitation generating activity in the atmosphere for this to be a total bust in terms of rain versus snow. It's gonna snow. The question is just quite how low. Is there major snow accumulation at 1,500 feet along the north coast and Mendocino Lake counties? That's a little bit speculative, but if you're up above 3,000, 4,000 feet, it's going to be pretty much all snow all the time after the first few hours today. Precipitation intensifies overnight tonight and probably peaks sometime on Friday into Saturday in most places. Again, lower elevations, it's going to be cold and breezy and wet, but this will not be a super high impact storm. This will not be a damaging windstorm at low elevations, nor will it produce all that much flood risk. There's some risk of minor flooding along the north coast where a number of inches of rain will fall, but again, the north coast is very wet. Minor flooding is not uncommon up there this time of year. I don't think there's going to be any major flooding, and the risk of significant flash flooding elsewhere is not zero, but it's low. And in Southern California, this probably won't be a heavy rain event. This will be more of a light to moderate rain event, so upping your late February or early March rain accumulations, which are already well above average, pushing them even higher, but probably not causing too many new flood problems. Places where soils are saturated, there could be a few mudslides or an additional landslide, but this won't really push the envelope too much in all likelihood down south. The other thing that we will see, though, including in coastal areas and lower elevations of this storm, is potentially some significant thunderstorm activity. We've seen this, again, with almost every storm system so far this year, and this does not appear to be an exception. I'll show you some satellite imagery about why this is pretty obvious in a moment. But once again, cold air aloft, there's a lot of convective activity behind the cold front already visible offshore, and once again, we still have unusually warm near-shore ocean temperatures, which are increasing that low-level atmospheric instability, especially when we have such cold air aloft. So I would expect coastal thunderstorms this time, less likely to bring damaging winds or brief waterspouts or tornadic spin-ups than the last rounds. This doesn't look quite as favorable as the last time, but what we will likely see in this case, given the cold air aloft, is a whole lot of small hail. So not lots of large hailstones that cause damage, but instead just large volumes of small hailstones that don't really cause damage unto themselves, except for crops and gardens potentially, but definitely create a bit of a road travel hazard. If you have one of these cells move over 101 or Highway 1 along the coast somewhere, along the north coast or into the Bay Area, we sometimes see these accumulating hailstorms where people crash into each other because they go around the bend and suddenly the road is covered in BB-sized or pea-sized hailstones. So not a big severe thunderstorm risk with this one, but a whole lot of small hail plausible with some of these cells along the coast, and certainly lightning always a hazard anywhere it occurs. So probably will be some thunderstorms, sub-severe thunderstorms that could produce a lot of hail, and as always heavy downpours, so local creek and stream flooding possible, but this probably won't be a big flood event. This is really trending much towards being a major snowstorm blizzard event, much more than anything else. And so more net beneficial than harmful at lower elevations, and this will definitely bolster the Sierra snowpack, but it's going to cause a lot of certainly extreme travel challenges and disruptions this weekend, and possibly other issues too, because when you see snowfall this heavy, you start to see issues with structural snow loading on roofs of buildings, certainly power infrastructure problems, and there's a real element of whiplash effect going on here as well, because as was mentioned earlier, this was not a good start to the snow season. Many places like South Lake Tahoe, I was there in early January, and there was essentially no snow on the ground at 6,500 feet in early January. That was during Operation Sierra Storm. And one of the things I talked about in that meeting was this notion of snow whiplash in a warming climate, where it really looks like that the average snowfall is decreasing and the worst snow years are becoming even worse, but we're still getting these individual very extreme snow events. These sometimes record-breaking 1 to 5 day snowfalls. And so this sort of creates a challenge, because most of the time you're dealing with less snow, but every once in a while you're dealing with even greater snowfalls than you were used to historically. And that's difficult to manage, right? Because you still have to have all the infrastructure in place to deal with the heavy snowfalls, the snow plows, the utility crews, even just stuff you have in your garage, snow shovels and whatever. But then you don't use it most of the time, so it sits idle. And then, you just aren't as accustomed to dealing with the heavy snowfalls. I know that there have been folks who moved up to the Sierra Nevada in the past few years who last winter, with the epic snowfall then, were really caught off guard and had huge problems dealing with it because it was just outside of their historical experience in the past 5 or 10 years. Last winter's snowfalls were incredible. And what's going to happen this weekend will be a taste, once again, of last winter. And this storm could rival some of the big ones from last winter. Again, even in a year where overall the snowpack has been a lot less impressive and when conditions have been unusually warm, more often than not. So this interesting notion of how we're still seeing these really extreme snowfalls that are remaining as intense as they have ever been, and perhaps even getting a little more intense, even as the average snowpack declines and as the number of really terrible snow years increases. Those are not necessarily contradictions in terms, because, as you can imagine, even in a warming climate, you still sometimes get an atmosphere that's cold enough for snow, right? But also in a warming atmosphere, the water vapor holding capacity of that atmosphere increases exponentially with increasing temperatures. So if you have this combination of warmer but still cold enough for snow in some of these events, you're going to see more extreme individual snowfalls. But for events that were kind of marginal temperature-wise to begin with, you're going to see less snow or no snow at all. Because you're on the wrong side of the freezing line. And so there's this tension between these two competing factors in a warming climate when it comes to snow. The obvious one, of course, is as it gets warmer, you see temperatures that are increasingly on the wrong side of the freezing line, more often than not, and in more places than not. But on the other hand, in places and at times, in any given place, when it's still cold enough for snow, you're seeing more atmospheric moisture by virtue of the fact that it's warmer. than it used to be. And so you actually see potential for extreme snowfalls that either don't decrease really with warming or maybe even increase in some places. And there hasn't been a whole lot of research on this, but there is some indication that this sort of phenomena it may be unfolding along the eastern seaboard of the U.S., where recent winters there's been very little snowfall on average, but every 5 or 10 years there's this massive multi-foot snowstorm in places like New York City or Washington, D.C., places where there used to be more regular light to moderate snowfalls. Those have almost gone away entirely, but we still get the really big ones periodically. And it's reflected by the notion that in places like the Arctic, surrounding the Arctic Ocean, snowfall is likely to increase by a huge margin in a warming climate. Not because it's getting colder, this is actually the fastest warming place in the world, but because even as it warms rapidly, if it's minus 20 degrees centigrade in the Arctic and you add 5 degrees to that, well, it's still minus 15 degrees. That's plenty cold enough for snow, but you've gained a lot of extra moisture by warming the atmosphere by 5 degrees centigrade in that part of the world and by melting some of the sea ice up there. So anyway, a bit far afield, but this notion that you can sometimes see diverging trends in mean and extreme snowfalls in a warming climate that are a function both of the background temperature, geography, and your position on the continent. So interesting food for thought there. And what I want to show now is some satellite imagery. So I'm gonna share my screen. What you're seeing right now is not yet the satellite imagery. That's the weather modeling. But let me pull up the satellite first. All right, so that should be what you're seeing now. A few things to note about the system. So the system that we're talking about on satellite, in many ways, doesn't look as impressive as storms earlier this year. So this is the cold front. You can sort of see it. It's clearly defined, but there's barely any clouds with it. These are like partly cloudy skies with some low-level cumulus and stratocumulus out over the Pacific. That does not look like a particularly powerful storm front, right? Over here, these are just marine stratocumulus. There's probably not even raining under these clouds. But if you look to the north into the cold pool up here, boy, oh boy, look at this. Huge area of popcorn convective clouds, as we call them. So these are essentially all cold core convective showers and maybe some scattered thunderstorms. Literally hundreds of them. Look how many individual showers and individual thunderstorms are up here in this vast region, north and west of California and west of Oregon and Washington. A huge area of cold core cumulus clouds. That's towering cumulus and cumulonimbus clouds with a few embedded swirls. If you look closely, you can see one of them right around here where the cursor is. This swirl is going to pretty much make a beeline for Northern California this weekend. So what's interesting here, this is not a major atmospheric river. If you look, Hawaii's way down here. This does not have a strong atmospheric river nor a subtropical tap. So this is the opposite of a Pineapple Express type event that we've seen earlier this winter. But instead, what we see is this huge plume of cold air and convective cloudiness up here. So don't expect to see some dramatic reds and oranges on the radar when this front comes through. It really is not going to be very impressive. But of course, in this case, that's really not what is of interest. It's actually all of this stuff behind the front that's interesting. And as this very cold and unstable air mass spreads over Northern California this weekend, all of these little swirls and impulses are going to produce some of the most intense snowfall over the mountains as this moves through. And of course, this is going to bring those heavy showers and thunderstorms with small hail accumulations along the coast that I mentioned as well. So again, the front itself, not super impressive, but this huge mass of cold air behind the front, very much so. And actually, there's one other thing I wanted to show on here briefly. And I'm actually pulling up the Weather West blog here because it's the easiest way to show it to folks, because this is actually where I have this image. And I'm going to zoom in on that if I possibly can. So this is just a back trajectory. Essentially, it's tracing the movement of an air parcel backward in time. And this is actually something I traced backward first, and then I went back in time and forward. The NOAA high split model is actually something you can run using a graphical user interface on the web, so you too can run the high split model. But the point is, if you look back about 4 days, so this is going back to, or 5 days now, and this is February 24th, this is where the air mass originated. So I chose a point over the Bering Sea between Alaska and Russia. This is about originating in the air at around February 24th. As you can see, what this model does is it traces then forward in time. So up through the present, the air will be about here, and over the weekend, the air is going to end up right over northern and central California. So my point is, this air mass this weekend is coming straight out of the Bering Sea and even northwestern Alaska and making a beeline for California. But the important part is that it's not doing so over land, so it could have made this trajectory in a pretty weird pattern. That might be a low snow level pattern where you might see very low snow down to unusually low elevations because it was traveling over land. Air masses, Arctic air masses that travel over land, they don't become as modified by the oceanic influence underneath, and so they maintain their extremely cold character if they travel over land. That's why it's so difficult to get low elevation snow events in California, because you need to get this air mass up here to do some contortions and essentially move due southward or even retrograde from northeast to southwest. In this case, that is definitely not what's happening. This cold air is coming in. It is originating in the Arctic, and it's coming to California pretty quickly, but it's doing so over the course of 4 or 5 days over the Pacific Ocean, which, as I mentioned, is warmer than average. So the lower levels of the atmosphere are being substantially modified by that warm ocean. It's being moistened and warmed, and although it's still a relatively cold air mass, it means that it's not an extremely cold air mass at the surface, but it is extremely cold aloft. And so what that does is increase what's known as the lapse rate, the rate at which temperature decreases with height, because it remains extremely cold Arctic air at upper elevations, but in the lower levels, it's been significantly modified, known as a modified polar air mass that is essentially warmer and moister, still cold, but a lot warmer and moister than it was when it was up in the Bering Sea. And that is what's causing all of these popcorn showers and thunderstorms that you see in this region, essentially filling in over the northeastern Pacific and bringing a whole lot of showers and thunderstorms that are going to move onshore and are going to be what create most of the interesting weather this weekend. And just to step through, here's a model representation of how this is going to unfold. And again, this is right now. This is early this evening. So as you see, this snow is just getting started this evening. It intensifies the overnight hours. A bit of a break tomorrow morning in relative terms, but it gets much worse. And by late afternoon, early evening tomorrow is probably the most intense period of snowfall. Starting to get close to maxing out the scale in terms of the snow intensity in the mountains. But look at this. Saturday morning, still widespread heavy snow. Saturday evening, continued widespread moderate to heavy snow. And then yet another wave. As we go Saturday evening, the snow re-intensifies and peaks once again Saturday night into early Sunday morning, tapering off a little bit later on Sunday, but still continuing. Widespread moderate to heavy snow, and then intensifying once again Sunday night. So there's going to be at least 3 distinct waves of extremely heavy snowfall over the next 72 hours or so across the Sierra. Finally, by Monday morning, a break. So I'm not sure the roads will all be open Monday morning because they're going to have to dig out from this weekend's extreme conditions, but at least the heavy falling snow and strong winds associated with the blizzard conditions should be done by early Monday morning. And so Monday will be a better day for travel because if the roads are open, they're likely to stay open Monday. Any periods that the roads are open starting about right now, between now and Monday morning, they're likely to close again imminently or be very dangerous to drive on in the mountains. And so these conditions later into Tuesday, things dry out, sunny conditions in fact, before a weaker but still cold system again later in the week brings yet more snow and coastal showers and isolated thunderstorms. And this pattern will likely continue through mid-March with occasional colder storms, probably nothing too extreme. So by far, the biggest event right now is what we're going to see in the next 4 days. And just to give a sense of the likely snow accumulations here, widespread 80 to 90 inch actual net accumulations in the Sierra Nevada. I mean, those are very large numbers because the peaks are going to be higher than that. And this is a somewhat conservative estimate. This is snow depth change. The actual amount of snow might be larger than this. This accounts for some melting and compaction. So 90 inch of actual snow depth, 90 plus inches of actual snow depth increase is a very large number. Also note, potentially accumulating snowfall in interior Mendocino County and much of Lake County. Not quite sure how heavy it'll be, but any amount of meaningful accumulating snow down to 1,500 feet can be a problem up there. And again, right along the north coast. No sea level snow, and this air mass isn't cold enough for that, but there could be plenty of small hail from those cold core thunderstorms. And as soon as you get up to about 1,500 feet, which happens pretty quickly along the north coast, very heavy snowfall possible down to unusually low elevations. Again, looking up just north of Lake Shasta. So again, at lowish elevations, not extremely low, but low-ish, down to around 1,000, 1,500 feet. Heavy snowfall possible there too. And of course, at 2,000 feet, 3,000 feet in the Sierra, that's well into foothills. They could be affected by multiple feet of heavy snow there as well. So that could cause some problems. So I'll leave it on the satellite and then go back to showing my face for a moment. All right, so I'm going to start taking a look at some of the questions that have come in. Take a sip of water as I do so, and then go from there. There's a question about the wildfire activity in Texas. I'm going to come back to it in a minute. Talk about California first. So a question from Paul Rogers about the climate change fingerprint. Is there a climate change fingerprint with this big blizzard, or is it just a large storm from the Gulf of Alaska? Well, they're not mutually exclusive statements. It is definitely a big storm from the Gulf of Alaska with, as I mentioned, an unusually direct pipeline for cold air directly from the Bering Sea. So this is not, by any means a record cold air mass. In fact, the air mass itself is the kind of air mass we probably see every winter in California, usually more than once in terms of how cold it is. But what is different about it is it is associated with unusually moist air with that cold. And that is where, with big snowstorms, we do see in some settings a climate change signal. Because as I mentioned, there's these competing factors. Climate change is making it warmer, which makes it more difficult for the snow to occur rather than rain in general. But when you do get a cold enough air mass like this one, you actually can technically get larger individual snowstorms that produce larger volumes of snow water equivalent, because again, if it's just cold enough but there's more moisture, you're going to get more snow. And with some storms in a warming climate, that's what's going to happen. With other storms, like we saw earlier this winter, we saw a lot of storms that were not just cold enough anymore, and with that couple degrees of warming that we've seen so far, push the freezing line to the wrong side of the rain versus snow threshold, and so we ended up seeing rain rather than snow. But with this one, this storm is cold enough that even with a couple of degrees of warming, it's still going to be cold enough for snow. But because of those couple degrees of warming, there's more moisture than there would have been 50, 60 years ago. And so this same storm 50 or 60 years ago probably wouldn't have had probably as much snow as is going to fall with this one. Would it have still been a big snowstorm and possibly a blizzard? Probably so, with the same synoptic setup. But would it have produced as much snow as this one is likely to produce? Perhaps not. In general, we should probably expect that the amount of precipitation in some of these really big individual precipitation events, whether they're rain or snow events, is probably around 10% or so greater than it would have been prior to the amount of warming that we've seen. In this event, 10% is nothing to sneeze at when you're talking about 5 to 10 feet of snow, right? At the upper end of that, that's like an extra foot of snow. So just to say that, some of the records that we might beat this weekend in terms of one-day snowfall, maybe we wouldn't have beaten them 50 years ago without that extra 10% moisture in the atmosphere. So food for thought. Now, that's a kind of a simplistic view. There are other things that are changing too. The vertical temperature structure of the atmosphere is changing as well. The fact that the nearshore ocean is unusually warm with some unusual convective instability, that might bump things up even further, ironically in this case, relative to that 10%. But I think that's a good, right now, with the amount of warming we've seen, my null hypothesis as a climate scientist is that the average heavy precipitation event in California, whether it's rain or snow, is probably about 10% heavier than it would have been without climate change at this point. Your mileage may vary. Some of them are going to be less than that, and some of them are going to be significantly larger than that 10%. But even if that's your baseline assumption, 10% is not a small number in the scheme of things. It matters a little bit less with snow because that extra 10%, if it's rain during a major rain event, really can affect the flood risk. Here, getting an extra 6 to 12 inches of snow with that 10% is notable, but it's still a big snowstorm either way. But I just don't think we can reduce it down to binary. Did climate change cause this event? That's sort of a meaningless question because climate change is involved with all weather events because they all unfold on a warmer Earth, which modifies all aspects of the atmospheric patterns that we see. But on the other hand, it's never going to be the only factor because we were going to have weather anyway. There was going to be variability in storms and extremes with or without climate change. And so although all of that weather is unfolding in the context of a warm climate, and therefore every weather event is affected by climate change, it doesn't mean that every event was necessarily made worse by climate change or changed in the same way by climate change. Some events are going to be not as strong as they would have been. Some events will be stronger. But overall, if you run the numbers and crunch the numbers, on average, extreme precipitation events are more extreme than they would have been. Extreme heat events are more extreme than they would have been. And snow is an interesting question because snow is related both to temperature and to precipitation. It is a question both of how cold it is and how heavy the precipitation is. And so that's why we sort of have those countervailing factors, one of which would act to decrease snowstorms through higher temperatures and more melting and things falling on the wrong side of the freezing line. But that increase in temperature driving an increase in atmospheric moisture, which would tend to increase the amount of snow that falls during events that are cold enough for snow. And so this is probably one of those events that falls more into that latter category, where it's cold enough for snow and there's more moisture than there would have been historically, so there's probably at least somewhat more snow than there would have been. That's how I think about these things. Yeah, several questions about the Texas fires, so I will touch on them by the end of the session. Stephanie mentions that it just started raining in Grass Valley. Not too surprising, this is starting out as rain in Grass Valley. It's a relatively low elevation, but you are going to get snow later in this event in all likelihood. Matthew mentions a mixed rain, graupool snow at 6,100 feet in Olympic Valley, which is, I actually think, a good sign in this context, because if it's already right at that rain-snow mix at 6,100 feet, the air is going to get colder and the precipitation is going to get heavier, which is going to drag down colder air from aloft sooner rather than later. So if it's starting out as the rain-snow line is right around 6,100 feet, that means that probably already still full snow at 6,500 feet, and that level is going to drop steadily throughout the storm. By the way, I'm noticing a couple of weird visual artifacts, but it does not appear to be, in this case, the internet connection. So this may just be the fact that I have 11 different cables running into different ports on my computer. There might just be some electrical interference at this point, since I think that the actual connection right now is quite strong. So unless somebody tells me otherwise, I'm going to assume that it's working okay. By the way, side note, Xfinity and the electrical utility crews have been out almost continuously for 2 weeks. They've literally been in the neighborhood almost every day trying to fix the apparently incredibly extensive squirrel-related damage to the infrastructure. I have no idea how it got that bad without them noticing, but they've replaced almost all of the fiber optic cables for miles. Miles of fiber optic cables in multiple directions, and even some of the electrical connection boxes, which had different evidence of squirrel-related incursion. I kind of thought this was an excuse, but then I actually did a little bit of research, and I'm no expert in rodent-related infrastructure damage, but apparently as much as 15 to 20% of all fiber optic cable damage in the U.S. is caused by squirrels. So I guess that's a thing. Kind of funny. Anyway, supposedly this has all been fixed. Now, whether they've somehow squirrel-proofed the infrastructure is another question, so maybe this will arise again in the future, but I thought that was rather amusing. And that it's taken multiple weeks to fix the damage. Multiple weeks with probably 15 or 20 people in 5 or 6 different vehicles to fix, so probably not an insubstantial cost to those repairs. All right here. Yeah, some folks commenting that, in different parts of California, significant snow accumulations at 1,500, 2,000 feet can be a real problem, and I absolutely agree. And so some of those places that saw those issues last year might see them again with this event. Not quite as low, probably no one down at 500 feet or 1,000 feet, but above that could be a problem. A lot of folks, between 5,000 and 6,500 feet reporting mix of rain and snow. So this is probably as high as the snow levels will be throughout this event. They're going to drop from here on out. It's windy up in the North Valley. Craig mentions a gust to 52 in Redding and Red Bluff. So that's, enough to cause some issues. It's not an extreme windstorm, but it's a sign that the south-southeast winds ahead of the cold front are cranking, and that there is up valley flow, which can result in convergence and orographic enhancement of precipitation up in Shasta County, that's for sure. Yeah, as a comment that I was earlier talking about the cumulus clouds that might be thunderstorms and the satellite lightning detector is showing only minor activity so far. One piece of that is that a lot of those lightning detectors are only detecting a cloud to ground, or in that case, cloud to water strike, so they don't include in-cloud lightning. The other challenge is that sometimes when the cumulus clouds like that are so low topped, it's difficult for them to produce lightning if the whole air mass is so cold. There isn't always as much cloud separation or glaciation in the cirrus anvil top that you need for that charge separation. So some of these storms produce more lightning than others. The reality is, though, that those are still cumulonimbus clouds, even if they aren't producing lightning. That's stretching the definition a bit, because sometimes cumulonimbus clouds are, by definition, mature cumulus clouds that are producing lightning and have an anvil. But in these low-topped environments, sometimes you can get what are effectively cumulonimbus clouds because they have the glaciated anvil top. They contain updraft, they contain hail, they contain convective downdrafts, but they don't always produce as much lightning if the whole atmosphere is uniformly cold. So these may end up generating more lightning as they get closer to the coast and the surface temperatures increase a little bit. They may not be a huge lightning producer. There's a little bit of a mystery why some of these storms produce a lot of lightning and some don't produce a lot of lightning, but what is clear is those are all deep convective clouds. They're going to behave as if they were thunderstorms in terms of producing hail and downdraft winds and heavy downpours, even if they don't necessarily produce lightning. And they might end up producing more lightning as they get closer to the coast. That does sometimes happen as the water temperatures warm near the surface and as a little bit of frictional convergence near the coastline. It sort of amps up those updrafts. A question from Rob about why this storm is going to deliver so much heavy snow to the mountains and not that extreme of rainfall to the coast. Well, the main reason here is that this is a particularly effective snow dendritic kind of formation environment on the one hand in terms of the precipitation efficiency in the mountains. So the rate at which moisture in the atmosphere actually converts to precipitation falling out of the atmosphere is going to be much higher in the mountains than at lower elevations. And this is for a couple of different reasons. One is that these are going to be sort of very strongly a cold cloud phase type event where the actual precipitation is going to form as snow and fall as snow. So it's not forming as snow high up and then melting and turning into rain, but it's going to stay snow throughout the column. And sometimes that's something that helps these clouds attain a vertical structure that is very efficient in terms of squeezing out the moisture in the atmosphere. But the main reason really is that there are quite strong winds in mid-levels of the atmosphere that are not present in the lowest levels of the atmosphere. So these upslope winds are really going to slam the western slope of the Sierra Nevada quite hard. And remember that there are some warmer storms that do this too, where you get a fairly strong atmospheric river that mostly produces light to moderate rain at lower elevations, but where it just rains incessantly and heavily in the mountains for hours or days on end. This is kind of like that in the sense that the wind pattern is favoring this orographic uplift above a certain elevation but not below it. So you're seeing very strong orographic enhancement of precipitation. This is one of the reasons why we're not seeing a huge windstorm at lower elevations in California, but we're going to see potentially damaging winds up in the Sierra because these winds are very strong up at 4, 5, 6, 7, 8 plus thousand feet, but not very strong at the surface. So that's one of the reasons why most of the precipitation is going to fall above 3,000 or 4,000 feet. That's where those winds are strongest. As you have winds, essentially orographic enhancement really just means winds that intersect the topography. And of course, the air can't go underground, so it's forced to rise. When wind hits a mountain, it's forced to rise upward. And of course, upward motion is what helps the air mass cool and condense and form clouds and precipitation. And so when you have winds that intersect the mountain range like they are now, and they're particularly strong, as they are with this event, they do so with particular extremity. And in this case, these are very strong winds, preferentially at higher elevations, but at low enough elevations to actually intersect the topography in the mountains themselves. So that's the other reason. And the other reason really is that, when we have these cold, unstable air masses, sometimes the Central Valley and the coastal valleys are in a little bit of a rain shadow because there's uplift over the mountains, but then there's a little bit of downward motion on the leeward side, so the downwind side of the mountain ranges, and there isn't quite enough convective instability for those showers to intensify over the lowland areas, but there is just enough conditional being the keyword, instability, for those convective lines to reinvigorate over the mountains. Given a little bit of a kick by that orographic influence, they can really take off. Sorry for that gulp of water. Sometimes talking for these long straight hours can be tricky. A general question about whether frigid air from aloft can ever descend in a downdraft scenario that would push out the sea-warmed air in places. Yes, that can happen, although it's inherently localized. So a downdraft in a thunderstorm could do that, for example. It still doesn't. That's why sometimes you can see. Sometimes in a forecast you'll see snow level, X number of feet locally lower and heavier showers. Well, that's exactly why. It literally pushes. Usually, there's a limit to how much that can, how effective that can be. On the West Coast during these sorts of events, sometimes you'll see a snow level that's maybe 500 to 1,000 feet lower and very heavy convective downdraft precipitation. So, occasionally that can happen. But it doesn't work on larger scales because if you had downward motion in the atmosphere, On large scales, you just wouldn't have precipitation or clouds at all because downward motion is very unfavorable for clouds or precipitation. So once that starts to happen on a large enough scale, you just get a cold, clear air mass, which again is why we tend to see either very cold air masses or very moist air masses in California, usually not both at once, and that's part of why this storm is unusual in that it's pretty cold and it's sufficiently moist at the same time. Comments that I-80 is already closed eastbound. All right, I-80 is closed both ways. There we go. Or not. Well, I'm never an official source for this sort of information, so check the Caltrans website. Your mileage may vary. But if it's not closed yet, it probably will be sooner rather than later, and it's already getting to the point where if you haven't already left, I wouldn't recommend leaving. Jack Lee asks, does the popcorn appearance by satellite suggest lots of brief, potentially intense storms as opposed to just continuous snow rain over large areas? Yes, that's exactly what it suggests. Although as this moves inland over the mountains, it will fill in. But the precipitation along the coast and in the valleys will be more periodic and showery. It could be heavy showers, but it will be broken precipitation and probably no major, well-defined cold front rain band in this case. All right, so now I'm going to dive into the fires a little bit in Texas because several people have asked. And then after that, I will take one more look at the questions that have come in since then and then perhaps call it an hour. So the first question was from Rachel. Rochelle. I'm wondering on if you could touch on the Texas fires. Thoughts on how there have been so many of these fast-moving and impactful fires in recent years and beyond in the West. So, just to set the stage, the location where the recent wildfire activity took place was on the southern plains. So, I think it's a little bit of a stretch to call this the West from a Western U.S. Perspective. The southern plains are a very different environment than, say, the Mountain West or the West Coast. It's really central U.S. fires, I think, is what I would call these. And fires in the Great Plains are different in several ways from fires that we tend to see in other parts of the American West, partly because it's the central U.S., but partly because both the ecology and the human landscape and the climatology are all quite different. These are primarily grass fires because, of course, you're on the plains, and the predominant vegetation type on the plains, certainly in its natural form, is grassland. But even now today, in many areas where there has been intensive agriculture this time of year, there's a lot of rangeland, and a lot of that is also grass, or in any case, relatively low vegetation, but fairly contiguous vegetation. And of course, it's February, it's winter. So in part of the country that's cold, as is the case on the Great Plains, the vegetation is completely dormant this time of year. So the grass is brown and dead. So unlike California, you don't get nice green grass in winter. You get dead brown grass in winter. So it's actually a lot more flammable and a lot drier than it would be in the spring and summer in this part of the country, because the winter in many cases is the dry season on most of the plains, especially the central and the southern plains. And so the late winter into early spring is actually peak fire season across much of the Great Plains of North America. And so in a certain sense, it's not surprising that we're seeing big fires on the southern and central plains in February, because that's actually fire season in this part of the country. Fire season is very different, by the way, in different parts of the country. The whole notion of it being a summer and autumn thing in California and the western U.S. broadly is not universal by any means. In fact, there are many places in the world where fire season actually peaks in winter or spring. And this is largely true because of the vegetation seasonality. In California, you tend to see a green up of vegetation in many areas in winter, or it's just so wet in winter that even if it weren't green, it's not going to burn anyway. But in other parts of the world, where the wet season is also the warm season, so the spring and summer are the wet season, as is the case on the plains, those spring and summer thunderstorms are what bring most of the water there. The cold season coincides with the dry season. And so it also coincides with big winter storm season. So on the plains, you tend to get big cyclonic storms that form on the lee side of the Rocky Mountains that produce sometimes very strong winds and very dry conditions ahead of the cold front. And sometimes they can produce really warm conditions too. What sets the stage for what just happened, though, is it's not uncommon to see fires in the plains in winter or early spring, and it's not uncommon to see big windstorms or dry conditions this time of year. But what is unusual is that some parts of the plains saw the record warmest February temperatures in the days leading up to the fire. Some places actually saw their record warmest temperature for any day in the entire December through January record in history within the past week. This was especially true in the Midwest, in the upper Midwest, but was also true in some parts of Texas and Oklahoma. And so very unusually warm, in many cases record warm temperatures preceded this event, and then very strong winds followed. And that is almost always a recipe for problems in the wildfire world when you have extremely warm, extremely anomalously warm temperatures, really summer-like temperatures. It was in the 80s and even 90s in some parts of Texas before these fires occurred. And then the winds came, the cold front came, and there wasn't really any precipitation. It was just strong winds and a wind shift. And so we saw these really devastating fires. These were genuinely devastating fires. They did destroy large parts of some small towns. I'm not sure at this point what the death and damage tolls are, although it sounds like they're considerable, especially in terms of damage. I also don't know what the full acreage burned is, but it seems like it's well over 1 million acres in total. So that would be a very large fire by Western U.S. standards. And again, it's not quite apples to apples because you burn 1 million acres of forest at high intensity, and that's a very different fire than burning 1 million acres of grass at a somewhat lower intensity, because there is literally less carbon in the grass than there is in a mature forest to burn. And so you can still get a devastating wildfire. In fact, you tend to get faster moving wildfires in grasslands, especially under strong wind conditions, than you do in heavily forested environments, because it takes longer for fire to fully consume vegetation in a heavily, densely vegetated forest environment than on the plains. You can have a grass fire driven by 50 or 60 mile an hour winds that blows through it over the course of 5 or 10 minutes and it's there and then it's gone. But the downside, of course, is that it can move very, very quickly. And at one point during this event, it looked like there was a fire front over 100 miles wide. So imagine being out in the Great Plains during a huge windstorm and looking in both directions, and as far as the eye can see, in either direction, just this line of fast advancing flames with some towns and lots of ranches interspersed there. That's exactly what happened, where the fire burned across most of the Texas Panhandle and into Oklahoma. So again, at one point, over 100-mile wide line of active fire. Sounds like that one fire burned almost 1 million acres, and there are multiple other fires that burned hundreds of thousands of acres cumulatively. So these are among the largest, if not the largest, fires in Texas state history. And depending on the full damage toll, it sounds like hundreds of structures were destroyed, may end up being among the most damaging as well. So, folks saying, oh my God, there's fires in winter, this must be climate change. And the reality is, in this part of the world, fires in winter are what you would expect if you get fires. This is fire season. Is this the poster child for climate change influence on wildfires? Probably not, because the strongest influence of climate change on wildfires is in what's known as moisture-limited environments. So where there's plenty of vegetation, but where it's not always dry enough to burn intensely. That would be heavily forested, heavily vegetated areas. Somewhat less true of grasslands, which just by their nature tend to burn. In a natural state, they would burn with significant frequency in grasslands. But there is still, I think, even in these cases, a climate change angle because why was it as hot as it was leading up to these fires? It certainly wouldn't have been that hot without climate change. And that does matter because there is still a difference between dry enough to burn and just extremely tinder dry. And although we call these grass fires because they are mainly burning grass, that is the predominant vegetation type, once they start burning through groves of forest, there are still pockets of forest out there on the plains. And once they start burning through towns and ranches, then it's not just burning grass, it is burning trees. And there may not be nearly as many trees there as there would be, say, in a forest in the Mountain West. But there are, windbreaks of trees. There are parks. There are pockets of forest. There is urban vegetation. And all of that is just as much subject to climate change driven warming and drying as anything else. And so, although the vast stretches of land out there, it's mostly grass, that's not the only story. And so, why was it hot? As hot as it was leading up to these fires? There's a climate change element there. What happens to the vegetation inside communities, on ranches, these trees, the brush that you find in these places that isn't just either the native grassland or the non-native plants that grow there as part of the rangeland? Well, again, some of these in between the grasses, in between these dormant farm fields, is other stuff, and all of that. We saw that in Colorado. I saw that firsthand during the Marshall Fire back in 2021, where that was a mixed grass and brush fire with some groves of pine forest, smaller groves of pine forest mixed in. But after a certain point, it became a primary urban conflagration, and it was spreading from structure to structure. But how was it doing so? It usually wasn't in contiguous walls of flames, that it was in these sheets of ember storms contained in the gusts. And what was producing the embers and what was catching on fire? Well, it was these dry wooden plank fences. It was these pine trees in people's yards and in road medians and in city parks. And so in that context, there's this interesting question too about how climate change affects not just the natural vegetation as we're mostly used to thinking about it in the western US in terms of fires, but also how it affects the not so natural environment, the built environment, the fences, the wooden fences in people's yards, the actual dryness of the wood in structures themselves, the bushes that people plant in their yards, the trees that grow in city parks, the vegetation that's on road medians. All of that is still potential fuel for a fire, and it too is affected by how dry and how hot things are in the days leading up to an event. And so, I think that there's actually some other pieces that have been less scientifically explored in this space. On the one hand, this is not the prototypical climate change amplified type of wildfire disaster. Those are probably more focused on forested regions or heavily vegetated, very brushy regions. So, in other words, most of California and much of the West. In these grassland environments, there is a much larger, longer history of natural, enormous fires that would have occurred prior to human intervention and as a result of indigenous and cultural burning in centuries past, something that's being revived these days as well. But the point is, this is not a landscape that is a stranger to fire or even frequent fire. But what are the two big differences? Well, now there's these communities built on it. There's all these ranches that wouldn't have been there hundreds of years ago. And also, we are seeing warmer, drier events in the middle of winter, which turns out to be peak fire season in this region, which is a challenge. And there's some evidence out there that in a warming climate, we won't necessarily see more frequent fires in the Great Plains, but we might see much larger. So the very most extreme fires might become more intense. And that is precisely what we saw with this event. This was a particularly large and high impact fire event preceded by record warmth. So to the extent that there is a climate connection, this would be the kind of event where we'd expect to see it. Even though in general, I don't think the links are as strong as they are for wildfires in the American West, especially in forested regions. So this is why, earlier last year, I remarked that there were two really conspicuous extreme fire events in North America last year, one of which was on the island of Maui, the Lahaina fire, that was truly catastrophic, killed a lot of people and destroyed large parts of a town, that I said that yes, there are some elements of climate change in the Hawaiian Islands that probably make this somewhat worse, but it's not really the prototypical climate change amplified type of wildfire disaster. If you look closely enough, you can see some elements of climate change, but in that case, there are other factors that probably were significantly more important in terms of why that event turned out to be so awful. On the other hand, last summer we saw the incredible, mind-numbing fire season up in Canada. And that really is a prototypically climate change amplified situation. It's very likely that climate change played a very strong role in why the Canadian wildfires last year, some of which are still burning, by the way, dozens of the fires from last year are overwintering during a record warm and dry winter and will likely reemerge and cause new problems in the spring. All of that, that's just screaming climate change. And in the more temperate parts of the American West, by the way, the links still vary from vegetation regime to vegetation regime, but overall the links are strong and growing, unfortunately, as the evidence continues to stack up. But the main connection is through vegetation aridity, and the strongest connection between vegetation aridity and wildfire is in places where there's dense vegetation. In grassland environments, all it takes is a couple of really dry days to make it highly flammable, and so that's somewhat less sensitive to the warming and drying associated with climate change as in more heavily vegetated environments. But that also doesn't mean it's completely unrelated. It still matters how dry it is, it matters how hot it was leading up to the event, and it also matters what the humidity was during the event. We know that climate change in many continental areas is decreasing relative humidity over land during strong wind events, even in places where the wind events themselves aren't changing very much. So that's probably more than I planned to talk about the Southern Plains fires, but since it was a major event and there's a bit of confusion as to how unusual winter fires are on the plains and what the role of climate change might be, I did want to clarify all of that. So one more sip of water, one more look at the questions, and I'm going to call it a day. I got to keep writing. Do feel free to check out the most recent Weather West blog post where I talk about the upcoming snowstorm in a lot more detail. A couple questions about the forecast after this event. In general, a colder and unsettled pattern looks like it's going to continue, so a good pattern for some snow accumulation. I'm not really foreseeing any huge storms or any major flood risk. So all in all, after this big event, things become a little bit less exciting, but still active. And really, this is going to turn into a pretty good water year in California overall. Despite being warmer than average, the snowpack is going to be pretty good thanks to this huge dump of snowfall this weekend. And I think largely thanks to the El Nino strengthened jet in central and southern California, coastal southern and central California already are sitting pretty this year in terms of rain totals. And so everything else is kind of just a bonus at this point down there. All right, folks. Thanks for joining. I think I'm gonna wrap it up. There's a slight chance I'll do another pop-up live session tomorrow or Saturday, but I am gonna be traveling next week, so I probably will not have a scheduled office hour session next week. So stay tuned if there might be a brief one, short notice tomorrow or Saturday, but don't plan on one next week. And then the following week I'm also traveling, but we'll be back toward the end of the week, so might be able to do something then. Hopefully it all coincides with a window of relatively, not totally calm weather, but at least not extremely stormy weather in California. So having a bit of a reprieve from that. But again, the big deal right now with this upcoming event, extremely heavy snow and blizzard conditions in the Sierra Nevada starting right around the next few hours and continuing through Monday morning. If you're not already there or on your way, just don't try it. You probably won't make it. it probably won't be worth it. The ski resorts are likely not going to be able to operate through it, and a lot of stores, businesses may be closed. There may be power outages. You probably can't drive around. That's my strongest advice. Next week might be a different story once all the snow has fallen and it stops falling and the roads get cleared out and the power gets reconnected and the chairlifts start operating again. But this weekend, it's going to be rough out there. So stay safe, be careful, and I'll talk to you next time.